In number 3, we're asked to figure out where two planes intersect. Two planes can only intersect along a line unless they happen to be coincident or parallel, which obviously they're not in this case. So if we want to find our intersection, we can do that by choosing a parameter at some point. So we'll start off by writing our equations down. We're going to do elimination, so we want to find some variable that's, oops, sorry, let's put a 7 there. Find some variable that's the same. I'm going to bring the 3 to the other side just to make it easier. If I times this whole thing by 3, I'll end up with 3 x's, 6 y's, 9 z's, and 3 times 4 is negative 12 on the right side, left side, so bring it to the right side becomes positive 12. And I'm going to subtract. My x's will disappear. I'll get negative 5y minus 2z, and that equals negative 15. Here's where our parameter comes in. We'll call z t, and then we'll keep on going. Okay, so we make z t. We need to solve this for y now. So I'm going to bring the 15 to one side, the 5y to the right, just to make it positive. Divide everything by 5, and I'll get 3 minus 2/5 t equals y. And once I've got z and y, let's go back and figure out x. So one of my initial equations was x plus 2y plus 3z equals 4. And we know some things. We know now that y is 3 minus 2/5 t. We know z is just t. And we have this 4. So we'll expand our brackets. Minus 4/5 t plus 3t equals 4. And then we'll rearrange for x. So we'll get 4 minus 6 plus 4/5 t minus 3t. Or in other words, x is negative 2. And then 4/5 minus 3t is negative 11/5 t. Now, it didn't say what form to put this in. This is our vector, or sorry, our parametric form. We could put it back in the vector form if we wanted to. Our value, our point is negative 2, 3, and 0, plus t, and the x value is negative 11/5. The y value is negative 2/5. The z value is 1. And if you didn't like that version, and we can always multiply by a scalar multiple. Let's call it negative 5. And we'll get 11, 2, and negative 5. Oops, 5. Okay, and there's your line of intersection between two things. I also want to know the angle at which these two things intersect. We know we can find an angle by using our dot product idea. So if we take the normals from our two equations, 3, 1, and 7, there's normal 1, 3, 1, and 7. And if we look at our second equation, our normal over there is 1, 2, and 3. Normal number 2 is 1. Those numbers again, 1, 2, and 3. Well, we know that the angle that the normals meet at is the same angle that the planes meet at. So we can find our angle by doing dot product. So n1 dot n2 over the magnitude of n1 times the magnitude of n2. So what's that going to look like in our case? So our dot product will give us 3 plus 2 plus 21 over root 3 squared, 1 squared, 7 squared is root 59. And 1 squared, 2 squared, 3 squared is root 14. So we end up with 26 over root 59, root 14. If we take the inverse of all of that, we get 25.2 degrees.